According to pressure law, for a constant volume of gas, its pressure is proportional to its absolute temperature. In order to verify the pressure law, we need this experimental setup. So the setup contains a constant pressure apparatus with a pressure gauge, a thermometer, a stirrer, a beaker of glass, a tripod, wire gauge, and the Bunsen burner. This constant pressure apparatus contains a round bottom flask with about 500 cubic centimeters in capacity, and this pressure gauge, which is calibrated in newtons per square meters. The pressure gauge is connected to the round bottom flask by a capillary tube. The reason for using this capillary tube will be explained later. And also this thermometer is calibrated from 0 to 100 centigrades. Okay, that is the experimental setup. So according to pressure law, pressure is proportional to absolute temperature. Pressure is proportional to absolute temperature given that the volume of the gas is constant. So volume of the gas should be constant. Then we can write this equation in this form using a constant K. P equals KT. Then we can take pressure as the dependent variable y and temperature as the independent variable x. Once we get that, we can write this equation as a y equal mx. So the graph according to this theory should be like this. So P is the dependent variable, capital T is the independent variable. So this is a y equals mx graph. So it should be a line which goes through the origin of the graph. So it should be like this. So this pressure has units of newtons per square meters, then T, absolute temperature, that is in Kelvin. So in the experiment, what we are going to do is to get several values for pressure of the gas related to those temperature values. And once we gain those pressure and temperature values, we can plot a graph and check whether those readings agree with a similar graph like this. So if those readings agree on that, we can verify the pressure law. Okay, then let's consider how to do the experiment step by step. First, you have to place the bulb of the constant pressure apparatus, the thermometer and the stirrer as shown in the image. Then you have to start stirring. Then you have to turn on the Bunsen burner. Once the temperature is risen about 10 centigrades, note down the temperature reading and the pressure value. Before taking the pressure value, you have to make sure that the temperature remains constant for a while. So what you have to do is, once it reaches the required value of temperature, you have to remove the Bunsen burner and keep that temperature reading steady for a while. Then take the pressure value. The reason for that is that it takes a little bit of time for the air inside this flask in order to absorb heat and comes to the thermal equilibrium. So you have to maintain a certain temperature values for a while before taking the pressure measurements. In order to draw a graph, it is recommended that you need at least about 6 pairs of pressure and temperature readings. So you have to continue the heating. Once the temperature has increased by another 10 centigrades, again you have to take the pressure measurements and the temperature value, then note down that on a table. So the table is shown here. The first row has temperature readings in centigrades. Then you have to convert that temperatures into absolute temperatures by adding 273 and fill this second row with those temperature readings. And you have to include the related pressure readings in the last row of this table. So this row contains all the x values and last row contains all the y values. So pressure is the dependent variable and x is the temperature. Then you have to extract pairs of temperature and pressure values from second row and third row and plot a graph. So for the graph, y-axis should be pressure in terms of pressure and x-axis should be in terms of temperature. The units Kelvin and here the units newtons per square meter. Then you should have 6 pairs of readings. Then we can mark those readings in a graph like this. So 5, 6. Then what you have to do is to draw a base fitted line. So this line should be linear, and if we extend this line further, it should go through the origin of the graph. So in that case, the pressure law is verified if you get a graph like this. And if the graph is not like this, there can be errors in the experiment. So you have to repeat the experiment. Okay, that is how you can verify the pressure law. When it comes to doing the experiment, there's one concern. That is that the temperature should be increased very slowly and the stirring of water should be done more efficiently in order to keep a uniform temperature profile throughout the water. Another important note is that you have to use a capillary tube in order to connect the flask and the pressure gauge. The reason for that is, as you can see, the capillary tube is at the surrounding and this flask is in the water. So air inside the flask is at a different temperature and air inside this capillary tube is at another temperature. So these two air quantities are in two different temperature values. So you have to minimize the amount of air in this tube. So by using a capillary tube, we can reduce the volume of that air. So that is why we have to use a capillary tube. Otherwise, we cannot say that all the air is at a certain temperature.